This is Geometry Lesson 11.4, Proportions with Area. If the corresponding lengths of similar figures compare with a ratio of m over n, then their areas compare with a ratio of m squared over n squared. If we are trying to find areas and we have corresponding lengths in two different figures, like we have the heights or the radius or the diagonals, we have to make sure we square the ratio before we cross multiply and divide. And then going in the reverse, if we're trying to find their lengths, we would take the ratio and we'd have to root it, because that ratio would already be in squared units and we want it to be in regular units. Okay, so down below I have two examples. The first says two triangles are similar. The area of the small triangle is 75 square centimeters. Their respective heights are 12 centimeters and 20 centimeters. Find the area of the large triangle. So I would set this one up 12 to 20. That is the ratio that's the ratio of the heights, so the lengths on the two figures. On my next fraction, it tells me the area of the small triangle is 75 centimeters. So I'm going to put that on the top of the fraction. I know that this is the smaller height, so I want the smaller area to go with the smaller height. Here's the larger height, so I want the larger unknown area to go with the larger height. If I pay attention to my units here, this 75 is a squared unit. This 12 and this 20, those are just regular units. And that's why I need to square them so that all of the units will come out and my answer for area will come out in square centimeters. So I'm going to cross multiply, divide, and that gives me my answer for x. 75 times 20 squared divided by 12 squared. So I wanted to show you the options on how to type this on your calculator. I had to change it so I could see it at the same time, but so we do 75 times 20 squared divided by 12 squared. So I can type this with the squareds in there, and it gives me my answer 208.3 repeating. If you're not really comfortable with that, or your calculator doesn't really, you don't have a graphing calculator or a scientific calculator, you can do your individual pieces, like 20 squared and 12 squared, and just do the problem out that way. So 75 times 400 divided by 144. And that gives you the same answer. That was supposed to be an M. 208.3 repeating centimeters squared. Wow, that looks really bad. Centimeters. Okay. Next example says two rhombi are similar. A diagonal of the large rhombus is 18 inches. Their respective areas are 64 inches and 216 inches, square inches. Find the diagonal of the small rhombus. Okay, so I know their respective areas. I have the 64 small on top. I have the 216 large on the bottom. I know the large length is 18, and I need to find the small one. So I have these set up. Here I have my squared units, and here I have my regular inches, and I want my answer to be in regular inches. A diagonal is measured in inches. So I need to square root these values so that I can cross multiply, divide, and get my answer for the length of the small diagonal. On the calculator, I gotta clear this to bring up the calculator again. On the calculator, I can type that whole thing, or I can get the individual pieces just like I did in the previous one. So what I mean is 18 times the square root of 64 divided by the square root of 216 gives me my answer of 9.8. We'll round it. I could also root 64 and get 8. Root 216 and get 14 point, I'll round it to 14.6969. I'll use more of it just to get a more exact answer. And then do those individual pieces. And it comes out to be the same answer of 9.7979. Obviously, when I rounded this, I got my decimals different, but basically I got 9.8 both times. So whether you do the whole thing or you do the individual pieces, it comes out the same answer, 9.8. Wow, that's just, yeah. X equals 9.8 inches. Okay, that is it for the examples. Good luck on the exercises, and as always, let me know if you have any questions.